Hey, this is Mr. Mitchell with a science video. Write down the questions and you'll find the answers during the video and bring them to class. Here's the video. Today we're going to be talking about matter and molecules. Matter makes up all living objects in the universe and non-living objects. If it's a substance, it's matter, and all this matter is made of atoms. Now, not everything has matter in it. For example, light. Light does not have any physical substance in it. It does not include any matter. Sound does not include any matter also. But most anything else you can think of that has some actual substance contains matter in it. Now, matter must have mass and it must take up space. I'm going to get my little pen here. And speaking of mass, mass is how much matter is in an object. And I have off to the left here a bowling ball and a basketball. How much matter? Bowling ball and basketball are about the same size. They actually have about the same amount of matter, and yes, air does have mass. So they have about the same amount of mass, even though they're completely different in weight. You know, the bowling ball is going to be well heavier, many pounds heavier than the basketball. Weight is different from mass, even though it's close to being the same thing. Weight is the downward pull of object due to gravity. Gravity is what determines something's weight. What determines something's mass is what is inside it. Now, granted, you're going to have a mass of something about this size, and you'll have weight of about something this size, and you can compare them. I just have a strange example here because one's very light and one's very heavy. But mass and weight are not always the same. And probably the easiest example to give you is what happens if you take this bowling ball and this basketball to the moon. The mass would be the same. It still takes up the same amount of space. It still has the same amount of matter in it, but the weight would be different because the moon is much smaller than the earth. The bowling ball would weigh less. The basketball would weigh less. So mass and weight are close to the same thing, although weight can have some kind of variance to it depending on where you are. There's something called volume that is very similar to mass and weight. Volume is the amount of space something occupies. Now that seems like the same amount mass has, but volume can be empty, volume can be full. Volume, it doesn't matter how heavy it is, what the weight is, it doesn't matter what the substance is in it, it's something that is measurable. And we have formulas. What am I doing here? I can write this out. It's measurable. And we have formulas that can determine the volumes of stuff. Down here we have this rectangle, I guess you'd call this a rectangular prism with all kinds of different measurements with this rectangular prism. We have across this length is 6 feet, that's the length. The width is 3 feet. The height is 2 feet. And it happens to be that the volume of something like this is going to be length times width times height. So you can find out the volume, the space that is in it, how much space it occupies by a formula. Now volume is usually measured in something called centimeters cubed. And here you have centimeters, or in this case feet, which you can convert to centimeters. Feet, 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 and when you multiply them times 3, that will make them cubed. But anyway, there's a volume of formulas for spheres and cylinders and many objects which have simple formulas to measure the volume. But what if you have an irregular object? Let's take this little toy dinosaur, for example. This toy dinosaur does not have the dimensions, the easy dimensions like this particular rectangular prism had, not prism, rectangular box had. It's irregularly shaped. You can't have a formula for what a toy dinosaur would be. So, something that would really help in determining its mass or its volume would be displacement. I'm not going to write that out. But the displacement of water, whenever you take this toy dinosaur and put it in water, you know it's going to take up space where the water once was. So you see that the difference in space went from this line all the way up to this line. And you can actually calculate that from the difference in the water level in the graduated cylinder, and that will show you what the displacement is, which will tell you what the volume is. So that's how you would measure the matter, or the volume in this case, of an irregular object. Now, all this matter is made up of the same substance. All matter is made up of atoms, whether you have basketball or bowling ball or everything in between, or every other kind of object. Atoms, of course, are the smallest basic unit of matter. So small that even the best of microscopes cannot see a single atom. 1 teaspoon of water, a little bitty teaspoon of water, contains about 5, let me calculate it here, million, billion, trillion, zillion. Let me just write this out. It's a staggering amount of atoms that you would have in 1 little teaspoon. Not through yet. That's how many atoms you find in 1 little teaspoon. Even the best of microscopes cannot hope to get down to the atomic level. Now, this is a little bit different than a molecule. I had this on the wrong thing. A little bit different than a molecule. A molecule is when 2 or more atoms combine. You'll have a molecule. Now, a molecule is the smallest form of any given substance. For example, we have right here a molecule of water. We have 3 atoms here. Atom of hydrogen, well, another atom of hydrogen, and the atom of oxygen. So the absolute smallest unit of water you can get is a molecule, not an atom of water. It would be a molecule of water. And you actually have some substances where an atom and a molecule will be the same thing, but not that many. Gold is one thing. A molecule of gold will be an atom of gold. But here we have, most of them are a lot more complex than water. Here we have glucose, which is a kind of a sugar, and you can see all the complexities of the atoms that have to be in 1 molecule, the smallest particular unit of glucose. So most of them end up being something along those lines. Now, if you add more atoms, it's a different substance. Let's say you had another oxygen here. Then this is no longer water. It's actually H2O2, which is hydrogen peroxide. So just by definition, you have the basic unit and you cannot add or take away from that and still have the same thing. For example, you have oxygen, which turns out to be O2. If you end up with adding another oxygen atom there, then it becomes ozone, which is a different substance from oxygen. It just doesn't work out that way. These small substances, believe it or not, atoms and molecules, are always in motion. Now that's easy to see for some kind of gas. Molecules of gas are all the time moving around in the air. That's pretty easy to see. And you know, in liquid, it's not quite as easy to see. But if you were to put some kind of dye in water, put some kind of drop of dye in water, it doesn't stay there. Since all the molecules are moving, that dye ends up being spread out amongst all of them. So that shows you that it is in fact moving. But the thing that's hard to comprehend sometimes is the fact that solids have atoms that are vibrating. They're constantly moving. The desk that you'll be sitting on at school tomorrow, it is made up of atoms which are constantly moving. So you can say even though the desk looks like it's completely still, the atoms in there are moving. The pencil in your hand, same thing. The atoms in there are moving. They're vibrating. You just can't tell. And they form a regular pattern. That makes it a solid something. It's not by definition liquid or gas, but the solids actually have constant movement in them. And whenever we start talking about how the atoms combine to make molecules, we'll see how that constant moving is going to be changing things, you might say. Well, I hope you learned a little bit about matter and molecules.